Hello, today I will discuss a very interesting problem of the yesterday's weekly contest. Okay, so count paths that can form palindrome in a tree. Okay, so we have been given a tree, that is, we all know what is a tree, is a connected undirected graph that has no cycles, root zero. Okay, and the label of the each node will be from 0 to n minus 1. The tree is represented by a zero indexed array. Okay, parent of size n, where parent of I is the parents of node I. So what we have been given is that we would be given with an array of called parent, and which indicates, suppose it is 0, 2, 1, 2, 3, and so on. So what does this parent indicate is that for the 0th node, the parent would be minus 1. Why minus 1? Because since 0 is the root itself, so there won't be any parent of 0. Okay, for the node 1 the parent would be node 0. Okay, for the node 2 you can see the again the parent is node 0. So now it's understandable that what the parent I indicates. Okay, and also we have been given, you are also given an string s of length n, where si is the character assigned to the age between I and parent I. Okay, and we have to ignore s of 0. Why s of 0? I will tell you. So I have already told you that it is a zero based indexing. So 1 to 0 indicates the age. Okay, 1 and 0 indicates the age. And what is the corresponding character? Since we are at index 1, so the corresponding character is C. Okay, so I can say that the character assigned to the age between the 0 and 1 would be C. So that's why it has been given a string s. Similarly, 0 and 2, for the age 0 and 2 we have been given a, that's why it is a. Okay, and similarly for the age 3 to 1, the corresponding character is a. So it's quite obvious that the character assigned to the age between the 1 and 3 would be a. Okay, so I hope it's clear till now. Okay, so what we have to do is that we have to return the number of the pairs of nodes u comma v such that u is less than b, and the character assigned to edges on the path from a u to b can be rearranged to form a palindrome. Okay, so we have to return, let's call the pairs of nodes as valid if the if the path if the path between the two nodes comprise of the characters that can be rearranged to form a palindrome. What I mean is that, let's see that. Okay, so suppose if I consider the node 3 and 2, so what are the characters involved in the path? It's a, c, and a. So I can say that I can rearrange the character a, c, a to a palindrome 1. Okay, similarly if I consider the nodes 3 and 5, so the character would be a, c, a, and c. Again I can rearrange them to a palindrome. Let's see, a, c, c, or a, or either C, A, or C. So yeah, this is a valid pair. Okay, pair of nodes. So I have to return all the possible valid pairs in the given tree. Okay, and let's see the constraint. N can be at max. That is the number of the nodes. Would can be at max 10 to the power 5. Okay. So and S consists of only lowercase English letters. So how to approach this problem? What would be the brute force? The brute force would be that I would just generate all the pair of nodes, all the pairs of nodes possible, and we'll check whether this is a valid one or not. Okay, so what would be the time complexity of generating all the pairs? Obviously it would be n square, because I would have to use two nested loops. Okay, and now for checking whether it is a valid or not, I have to how to check now, the we are only left with how to check whether it's a valid path or not. Okay, so let's discuss that first. Okay, let's discuss it here itself. Okay, suppose I have been given this, and here the only character present are A, B, and C. Okay, now I represent it with before going to this approach. Uh, Please note here that what we are doing the how to check whether the path between the two nodes is valid or not. Okay, I have to check that. But what are the conditions when the path will be a valid one? How to what would be the checking condition? If I say that all the characters that appears in the path are having the frequency even even, then I can say, can I say that it is a valid, means I can arrange them to a palindrome one? Obviously yes. Suppose if A is 2, okay, B is also 2, again I can rearrange them. How I can tell that it is a palindrome one? It will be a palindrome one because the length would be even, and I can say if I will be having a character corresponding to the ith character. I will always have n minus I minus 1th character available, means the same character available. Suppose if I place A here, then I will be having A here to place. Okay, so I can maintain a palindrome pattern. That's why I am saying that if all the characters would be having the even frequency, then I can rearrange them to a palindrome string. And can I say that if only one character if only one character appears odd number of times, then also I can rearrange them to a palindrome. Yeah, I can obviously say, suppose if C is 1, C occurs one time, then I will place C here in the middle, and again it is a palindrome. So what are the two conditions? What are the two conditions for a string to be palindrome? Obviously, all the characters all the characters should have the frequency even. This is the first condition. Or what can be the second condition, in which I can get a valid uh, palindrome string, that all the characters would be having even frequency except one, and that except one, which means on at max one character can have odd frequency. So I can summarize that only one character can have odd frequency at most. At most, I am saying at most one character can have odd frequency. So now let's now we are able to understand the approach. Okay. So where we were implementing the solution to how to check whether it is a valid path or not between the two nodes. So how to check? Suppose here the characters are A, B, and C, although there can be at all the alphabetical characters available, but here it is only A, B, C. Okay, and I am doing just this test case for the explanation. Okay, I am considering that only A, B, C is available. Suppose I started at this. Okay, so I would assign 0 to all of them, 0 count to all of them. Now when I move on to the node 1, the count of C will become 1. Okay, and now when I move to suppose I am performing DFS. Okay, and now first what I am doing is that I am calculating the frequencies at each node, frequencies of all of the characters possible at each of the node. Then I will say that how I can obtain whether the path between the two characters is valid or not. Okay, first let me do this. Okay, so now if I arrived at node 1, then what would be the frequency of C? It would become 1. Now I had again reached, since I am only interested in odd and even, means the frequency is either odd or even, since I am only interested in that, so it doesn't matter So it is not required to actually count the frequency. I will just count modulo 2, modulo 2. Okay. Suppose if frequency is 5, then I will just take it as 1. And if it is 4, that is even, then I will take it as 0. Okay. So there is actually no need of to count to that's why now if I arrived at node 3, then I have also encountered a, okay, then the number would become 101. Okay. And now when I arrived at 4, what would be the frequency? I have also arrived as b. Okay. So it would become 0, 1 and 1. Why? Because in this path, in this path I have got a C and a B. That's why the bit corresponding to the B and C would be set. Okay. And suppose if I have gone further and I have again got a B, then what would I have done? The bit corresponding to the character B, it would have become 0. Why? Why? Because it has occurred even number of times. So I I have already explained that it doesn't matter to actually count the frequency. I would have to just uh, tell whether the frequency is odd or even. So I can just say in that in terms of 0 or 1, means in terms of binary. So until now, you would be able to just figure out that I can store this in terms of mask. Okay, mask of length 26, because at max 26 alphabetical characters can be there present in the uh, weight of the edges. Okay, so I can maintain a mask for each of the node. For each of the node, I will maintain a mask, which will say uh, that from starting from the root node, which is 0, what is the frequencies, what is the frequencies of each of the character, whether it is even or odd, corresponding to each of the characters, whether I can say whether it is or occurred even number of times or odd number of times. Okay, so I hope I am clear till now. So it was 0 initially. Let me do this in terms of ABC. Okay, let me do this in terms of, I am starting from the right to left, because in binary we go from the right to left. Okay, so it would be initially 0 because I have not encountered any characters. Now I have encountered C, so the uh, bit corresponding to C, which is index 2, okay, in binary, is would be set. So what would be the corresponding number? It would be 100. Okay, now I have encountered a, so the bit corresponding to a would become 1. Okay, and now when I go to 4, it would become 1, 1 and 0, which represents 6. That's why I am saying that it is representing a mask. Okay, now again I go to if I go I have chosen the node 2 from the node 0, means I am performing DFS. And suppose I have just chosen the node 2, then what would be the mask at node 2? It would become 100. Okay, and what would be the mask at node 5? It would become 1, sorry, it would be 001. The bit corresponding to node the character a is at 0th index. Okay, and the correct bit corresponding to the node character C would be at the index 2. Okay, so it would become 101. Yeah, suppose now if I want to query over the nodes 3 comma 5, whether it is a valid path or not. I have already defined what is a valid path. The valid path would be the that if I arrange all the characters in which occurs in the path between the two nodes which I am querying for, if all the characters can be arranged to a valid palindrome, then it is a valid path. Okay, and I have told you the condition for that, means at max one characters can have the odd frequency. Okay, so now if I say that 3 and 5, querying for the node 3 and 5, so I would just say, suppose what I can say, 0 to 3, this path can be considered as a combination of 0 to 3 and 0 to 5. Okay, so for 3 it is 101, and for 5 it is 101. So what does this indicating? For the node 3, the C appeared 1 times, A appeared 1 times, and for the node 5 also C appeared 1 times and A appeared 1 times. Okay, so in total, if I combine both of them, I can say that both C and A have occurred even number of times. So my condition has been achieved for the valid path. Okay, I can say that since all the characters have even frequencies in that path, so I can say that it is a valid path. It is a valid palindrome, valid pair. So can you tell me a bitwise operator which can just do this for me? Suppose if a bit is 1, means till from a node to the root node, if the character was occurring odd number of times for one of the node, and for the other node it was occurring zero number of times, means even number of times, so can I say that the combination would become 1? And if occurs both of the for both of the nodes it was occurring odd number of times, then it would become 0. Okay, and if it is occurring in both even number of times for both of the nodes, then it will again become 0. And if either of the for either of the nodes, if it occurs odd number of times, then it will become 1. So it's quite obvious that I would have to perform XOR operator. So if I perform XOR operation for the data present in these nodes, what would be the result will become? It would become 0, 0, and 0. Okay, since it has become 0, 0, 0, so I can say that uh, all the characters has appeared even number of times. That's why I can say that it is a valid path. And even if it was taken something like this, that one of the bit has become set, then also I can say that it is a valid one. Why? Because I have already told that at max one can have the odd frequency. Okay, so yeah, I would just traverse for all the pairs and I will just check this. I will just perform this XOR and will check whether it is taking a shape like this, means at max one bit is set or not. If it is, if more than one bit is set, then I can say it is not a valid palindrome. Okay, so yeah, I have discussed this approach. Let's code it, move on to the solution, then you will be clear. Okay, let's first of all create a graph. So the total number of nodes would be n. Let's create the graph. It will be actually pi. What is pi? I will declare as defined. Pi means I am creating a macro for the pair into command. As defined. Also I am creating a macro for the pushback. Now I would first create a graph for int I is equals to 1. Why I'm not starting from 0? Obviously there would be no edge from the 0 to its parent, because it doesn't have a parent. That's why it has the parent of 0 is equals to -1. Now there exists a edge between the node I and its parent, so I would have to just push back parent of I. And what is the weight of the edge? What is the weight of the edge? I can say Si minus A. Okay. G of parent I dot pushback. Okay. Again the now since it is a undirected graph, so I would have to just put on the entries for both of the nodes. Okay. Now my graph has been adjacency list has been created. So what I am left with only, I would have to just call a DFS function. Okay, which will start from the root node. Okay, G, and I would just create a pre which will store this value which I have already discussed. Okay, the value at the node which will store the value at the node. Let's run the DFS. Int v, int p, and vector in vector pi g, and then vector intersection pre, which will store the value. One thing I forgot to pass the value. Yeah, I have passed int var. Okay, so whenever I go to a node, I will just store this corresponding to that node. Okay, now I will go to every neighbor of this current node. Okay, g of b. If it dot, what does the it dot first indicate? It is the node. It was the node. Remember that it was the node, and the second was the weight. Okay, so if it dot first equals to parent, then I would have to just continue. Otherwise what I would have to do, I would just call dfs of v comma it dot first comma b. Now the parent would become this node and the child will become the current node. Okay, g, and then pre, and now what would the value will become? I have already discussed that I would have to take the, since I have to include this, but I have to take the XOR. Why XOR? Because if I move further, and if I found a character which has become even number of times, which with the inclusion of this character, if it has become it will be having even frequency, then accordingly that the set bit will change. What I mean is that, suppose till now the character A was occurring even number of times, and I am denoting it with 0. I have already discussed 0 means even and 1 means odd. Okay, and now if somewhere in the path I again strike A, then the bit corresponding to 8 will become 1. That's why I was talking. And if it was initially odd and now again I have encountered A, then it will become 0. That's why I am saying that I will have to take XOR. Okay, XOR with what? It dot second means I am setting that. Okay, suppose the number was previously this. Okay, means I can say that till that node the frequency of A was odd, and now again I suppose I go to an through a edge having the weight A, then what will be the number will become, which I am stating as mask. It will become 0 comma 0 comma 0. Okay, I hope it's clear now. It dot second. Okay, if you are not clear with this, then you should learn first of what is mask and bit manipulation. Okay, Yeah, that's all about this code. So I have this the value at each of the node with me, and now what I have is left with is that I would just uh, do a nested loop. Int j is equals to I plus 1, j less than j plus plus. I would just say what? I would have to just check whether it is a valid one or not. Okay. So how to check this whether this is valid or not? First I would check one. If it is a if it is a uh, case one, all the characters are having even frequency. Okay. So how I will just do this. I have already discussed that if it is root node and if I am at this ith node and I am just checking for the jth node whether it is a valid path or not, what I will do, the value at this node I and the value at this node j, I will just take XOR of them. Okay. So yeah, int new mask is equals to pre of I, XOR pre of z, and now I will check if mask equals to 0, then obviously it is a valid one. So I would just keep a counter, okay, named as answer plus plus, continue. Suppose if it is not so, means the second condition was what? Case 2 was exactly one character was having odd frequency. Okay. So how to check that? I will just have to loop from all the. I am just saying that I will have to just first I have first let me write, then I will explain. If new mask equals to num answer plus plus, and I will just break. Okay. So what I am doing with this line of code is that I will just check from for all the masks from 0 to 126 which will be having only one bit set. Means what I can say, suppose I am having only three characters. Let me explain just for three characters. What can be the three condition in which only one bit is set? Either this will be the set, either this will be set, either this will be either this will set. So what is the corresponding number? You can easily see what is the corresponding number with corresponding to each of the cases. Obviously this. That's what I am doing now. I am just setting one by one each of the character as set, means I am assuming that this character will be having odd frequency, either this character will be having odd frequency and either this will, if even one of these is holding true, then I can say that it is a valid palindrome. Okay. So yeah, that's all about the code. Let's run over the return the answer variable and see whether it's running fine or not. Okay. Oh, sorry, it was defined. Again compile mask equals to 0. Oh sorry, it was new mask. So yeah, it is giving right answer. Let's submit it. Although it will not pass because it is even greater than n square. C into n square. Yeah, time limit exceeded. Let's see how much test cases it has passed. Yeah, it has passed only 662. It has failed over 3 test cases. So that would be due to the time limit exceed, because obviously the time complexity is n square into I am not saying exactly 26, but it would be some a constant one. So I can say even greater than n square. So now how to optimize this? The optimization is quite simple. If you would have done a problem like in an array, in an array, uh, if you had done a problem like the count of the pairs having the XOR value 0 or either a power of 2, either a power of 2. If you would the I can transform this problem to that problem only. Okay, because here on also what I am doing, is it required to do this inner loop? If I have just modified approach to this solution, means if you would have done such problem, although I will discuss, but let's discuss that. Okay, so what I will do, that I will traverse from the left to right. Let's first write the code for that approach, and then I will dry run over that. Okay, so yeah, I am having already present with value at each of the node. Okay, so what I will do is that I will just maintain a map. Once I dry run over the example, you will be cleared with the solution. Okay, I will first frequency of 0 plus plus. Now I will iterate from I is equals to 1, I less than n, I plus plus, int new mask pre of I. No, I will just check answer plus equals to frequency of pre of I. Okay, and the second case can be for the exactly one odd frequency character, odd even. Okay, and the second check is for the odd. The check is also the similar as the previous one. I will just run for all the. Let me first run the code. Why it is giving runtime error? Let me check. On map int comma in 0 plus plus I less than n, I plus plus. Okay, oh sorry, it was z plus plus, it should be j plus plus. Yeah, it is giving correct answer. Let's submit it. So it got accepted. Let me just now what I have done in the optimal solution. uh, I have already discussed what was the values present with me. Okay, 0, 1, 2, then 3, then 4. Let me create another at index 5. Okay, so what was the value corresponding if I considered uh, C, B, A? I've already told you that in the bitwise we do in from right to left. Okay, so what would be the value at node 0? It will be 0. When I go to node 1, then I have encountered a C, so what would be the value at? It will be 100. It will be 100. If you would have ever done that problem, the count of the pairs having the XOR 0, then you would have got the approach. Okay, now when I go to 2, it would be the bit corresponding to A would be set. So 0, 0, 1. Okay, now if I go to node 3, what would be the number look like? It would be like 101. And similarly for the node 5, 101. And for the node 4, it would be 1, 1 and 0, because in that path only C and B are present. Okay, now I am available with this array, so I have maintained a frequency. Let's name it as frequency. Okay, in my code, frequency. So I am not starting, I am starting with from node from index 1. Okay, so I have to just count the frequency of the value at this node, which is the root node. So frequency of 0 is 1. What I mean, I will say. Okay, now if I am at index 1, what is the value? It is 4. If I convert this binary representation into decimal 1, then it would be 4. Okay, so what would be the number? What would be the number? Just hear me properly. What would be the another number with whom if I XOR this number, I will get 0. I will get 0. Why I am searching for 0? I have already explained. The first condition was for the valid palindrome that all the characters would have the even frequency. Just remember that. So I am just searching for all the numbers which will give the value 0 after XORing with 4. So obviously it would be the same number. It should be the same number. So the first check is this: all even answer plus equals to frequency of prefix I. Means I am searching for the frequency of the same means the nodes having the same value. I can be sure that if I do this, then the XOR if the XOR between the values of that two node would become 0, then obviously I can say that the path will be valid between them. Okay, so the first check was for the even, and now for the odd one. How can I check this? The value is 100, 100. Okay, so if I just tell you that if I allow if I allow what was the two condition? Either all the characters having the even frequency, or only one of them would be the odd frequency, would be having the odd frequency. So obviously it would be something like this. Suppose if I that's why I check for uh, all the valid combination which will be having only one bit set, and which can be possible with three bit, since I am explaining for only taking three characters. Okay, so what can be those three? It will be this, either of these three. Okay, so I will just check all of these three. Means I will just XOR them one by one with 4, which is the value at node 1, and will search for their frequency. Okay, so it is 0. So yeah, I have found 0. So what is the frequency of 0? It is 1. So I can say that with one node there exists a node which will be having till now, which I can say that that will be a valid one. And you can see here 0 to 1, it is a valid palindrome. Why? Because it is only one character. And you can see here also. Okay, that's why I was just checking for this. Means I was just setting character corresponding to all the 26 characters one by one and taking prefix and taking XOR with all of them. Okay, and was just uh, adding the contribution of that new mask. Okay, so now I would just dry run. Okay, so now when I am at node 4, first I will check for the all the having the even frequency. So I will just search for 4, but you can see frequency of 4 is 0, so it will not count as for the contribution, it is 0 plus. Now when I just check for this, means setting all the characters one by one, set bit 1 to 1. So for the this was the number 0, so if I just set it again 1, then I got 0, and I have already counted the frequency of 0 as 1, so I can say that I have got 1. Okay, and now if I arrive at 2, not 2, it is 0 0 1. I will first search for the search for a node having the frequency 2. Why? For the even number of even characters case. Okay, so obviously I would not get any I have not encountered any value frequency 2 in the up till now. Okay, so it would not be that case. So 0 plus, I would just set one by one all the frequency, all the character, all the bit 1 and take XOR. It would become 1 0 1. Did I have encountered 5 before? Obviously not. Okay, so what can be the second possible if I take XOR with this? So it would be 0 1 1 0 1 1. Did I have encountered 3? Obviously not. And if I just do this 0 0 1, so taking XOR with this, it would become 0, it will give 0. So I have already encountered a 0, so obviously the answer would be 1 here also. So if I do this for up till this now, I will get my answer. I will just recommend you just to try run for another test case. You will come up with the uh, you will obviously understand the solution. Okay, thank you. So let's first discuss the time complexity. It would be big O of n into 26, n into 26. So it should pass obviously, and space complexity should be big O of n. Thank you.